start the recording. Perfect. All right. So here's the scenario. You see all the items that have been identified within this topology. What I'm going to do is have you guys walk me through, okay, how, we're going to go through step by step, walk me through how a PC, right, that's on a separate local area network would get an IP address from a DHCP server that's on another network. We're going to cover layer 2, we're going to cover layer 3, and we're going to cover in-depth spanning tree, that you'll see on the exam. We're going to cover routing, you'll see on the exam. We're going to cover, a lot of things. So again, you guys are going to be called randomly. Looks like somebody else joined. Hey, Lamar, see you're in. I'll go ahead and do a quick little debrief as well. But yes, any questions, guys, after explaining that?
None for me.
All good.
Okay. All good? Let me wait for Lamar to go ahead and join audio before we get started, just in case. Hey, Lamar, you there?
Yep.
Hey, Lamar, you there?
Can you hear me?
Hey, I can hear you, buddy. What's going on?
Hey, how's it going?
All right, pretty good. Just wanted to, I saw you jumped in roughly a second ago. I just wanted to go ahead and go over what we're going to do. So we're going to first go over the theories. Of course, I'm going to pick on you guys randomly. You're going to walk me through, how the packet is going to look at each hop. Okay. I'm going to ask you some theory questions that you've seen on the CCNA. I'm going to ask you guys to explain it. So good chance for you guys to, of course, make sure that you understand the theories before you guys take the CCNA exam. Okay. We're going to cover layer 2, layer 3, most of the technology that you're going to see on the exam. So, one thing I do want to say, this is a safe zone. It's okay to be wrong. Nobody's perfect. I bring down networks every day, right, Claude? I think that's that's my job title. I bring down networks and then I fix them. So it's a weird job title, but I'll take it. That comes with the job of being an engineer. But I'm happy. So I'm gonna call you guys randomly. So if I stop you in the middle of answering a question and you're about to answer another question, I'm gonna stop you because I want one of your other colleagues or teammates that's in this call to go ahead and answer it as well. Okay?
Thanks, David.
All right. So with that being said, okay, we'll go ahead and get started. Hey, Ramsey, how you doing?
Good. I just wanted the prime question is, are all the ARP tables cleared out? There's nothing in the ARP tables, right?
We're not worried about that at the moment. We're just going over theory and logic. That's it.
Okay.
We'll touch the ARP table once you guys get into the device and start troubleshooting.
Okay.
Okay, cool. So the first packet, like I told you, the situation was, I already explained it for Lamar and for folks that jumped in a little bit late. So what I want you guys to explain to me, and I'm going to ask each and every one of you guys, how the packet is going to look at each hop. Okay, going from PC 1 to server 1 to get an IP address. Okay, you're going to have to know a few things. Feel free to take your time. There's no rush to answer the question. If I ask you a question and you say, all right, give me a minute, feel free to take your time. Okay. So with that being said, Ramsey, PC1 wants an IP address. What is the first packet that it sends out on the wire?
Well, my question would be, does it have that address in its routing table?
Which address?
The destination IP address or destination MAC address.
Okay, so it doesn't need a destination MAC address. It's just trying to request an IP address. So what would happen? What protocol do we use in the networking world to request an IP address automatically?
DNS?
Keep going, you're close. The other D word.
Is that the
DHCP?
There we go. There we go.
Oh, so it doesn't have an IP address.
It does not. That's why it's blank.
Okay. I caught it. Okay, yeah. So The PC does not have an IP address, and so in order to get it, it would use the DHCP server DORA.
Perfect, Dora, excellent. So what's the name of that packet that PC1 sends out, and what's the source, destination, MAC address, and the source and destination IP address whenever it leaves that PC?
The Discover packet will have the Discover packet for the destination would be the DHCP server.
The destination MAC address?
Oh, well, it's going to be inside its network. So it should have it in its ARP cache.
We're still at layer 2. We don't have an IP address yet.
Then it would be, I would expect it to be the DHCP's MAC address.
Okay, all right. So me and you both being engineers, let's walk through this, okay?
Thank you.
No, it's all good. It's all good. That's what we're here for. So, right? So that Discover message, right? It's sent on to the wire, okay? That DHCP Discover is the PC doesn't know, who it is, right? And the PC.
Yeah.
Go ahead. You want to go ahead?
Oh, yeah. So it's going to be all Fs because it doesn't know a broadcast.
What are all Fs? A broadcast. Okay.
Broadcast packet. Yeah. Thanks for walking me through that.
No worries. No worries. Now, Ramsey, we're going to go a little bit deeper in the theory. What is that broadcast message doing within that network?
Requesting an IP address from the DHCP in its pool.
Yes, a little bit further though. What does a broadcast message do?
It sends a packet out all the ports of the switch, except for the one it came from, to reach the DHCP server.
Exactly. Perfect. Great job. Carlos, how you doing?
Not bad. What do you got?
All right, man. So Ramsey helped you out. He told you the destination MAC address of that first packet that's leaving PC1, that DHCP Discover. Now, what's going to be that source MAC address?
The source MAC address is going to be the original PC that's sending the request.
Hey, I'm not sure if it's just me. Carlos, I can barely hear you, buddy.
Oh, can you hear me now? Is it better?
It's a little bit muffled. Is that just me, guys?
Yeah, am I not coming in clear at all, or?
It's just a little fuzzy, but I think it's fine. This is your mic.
It's a little bit. Yeah.
Sorry. The source is going to be the original PC that generated the packet, PC1.
Okay, perfect. And what's the IP address?
The IP address of the PC, it still doesn't have an IP address, so it's got a
That's a good one.
I don't know.
It's okay. It's okay. It's okay. So Carlos, let's work together on this as engineers, okay? So me and you are an engineer, right? Let's think about this logically, okay? So like me and Ramsey, the other engineer we're talking about, it doesn't have an IP address. So that means the fields, right? Since it represents a decimal number for each octet, right? It doesn't have an IP address. So it's going to be 0.0.0.0, right? Because it doesn't have no values.
Oh, okay. Yeah.
Right?
Okay.
Same with the subnet mask. Is that right? I mean, that makes sense?
Yeah, it does make sense.
Perfect. Okay. Now, Jose.
Yes, sir.
What's going on?
It's going.
I won't bite, brother. I won't bite. So with, we're going based off of the engineer, Ramsey being one of our engineers that was first working with this. Coming back to you, we're talking about this DHCP Discover packet, right? And how it's going to look. What is going to be that destination IP address and why?
Well, I mean, the computer does not know the IP address of the server, so I'm assuming most likely it would send a broadcast also address
Okay.
for the destination, and because it doesn't know what's the IP of the server, and
Okay.
the broadcast address, I believe it would be the just like a 32 mask,
Okay. And what's that address? Tell me.
255.255.
Nice.
Yeah.
That's what I was looking for. Excellent. Now, Jose, explain to me, why does it have to be that?
Because it is like the computer just doesn't know, or like what's the address. So basically how the broadcast message is just the computer screaming like, oh, any, like, where are you? I'm trying to find a server. So
Mhm.
I think that is why the pack is looking like that, because the computer's trying to
Ex-
discover.
No, you're right. You're right. Absolutely. Right. And just to keep it simple, right, guys? Because I don't want you guys to get too flustered up whenever you guys get into the exam. Let's keep it simple, right? Just like Carlos said, the MAC address is all F at layer 2. That means we're doing a broadcast. So at layer 3, we're going to do a broadcast as well. We're going to keep it at 255. It needs to match up with that destination MAC address. Make sense, guys?
Makes sense.
Yeah, it does make sense.
Awesome. Awesome. All right. So it leaves out of here. Who else do we have in here? Oh, excellent. Okay. So it leaves out, it gets on the wire, right? Lamar. So the broadcast gets sent out by the switch, all ports, just like Ramsey was saying, it gets sent out all ports except the ones that it received on, and it reaches R9, right? What does R9 do with that?
Give me 1 second. You're referring to the switch?
Yes, PC1 sending that DHCP Discover packet and sending it to the switch, and the switch forwarding out all ports. Since, from what Jose and Carlos stated, it's a broadcast message, so that's the behavior it's going to do. So when it reaches R9, how is R9 going to respond to that packet that it receives?
The right. Okay, I see it now. So it's gonna basically look to see if the destination in which it is looking for is within its routing table.
Why?
Because that's what routers do. That was like the initial check.
So it's
because if it's receiving package, it has something to do.
Correct.
Hello?
Correct. So it's receiving a DHCP Discover message, and it's looking in its routing table for a broadcast address.
Yes.
Positive. You sure?
So normally how it goes is it receives the packet.
Mm-hmm.
If it doesn't know where to basically direct that traffic to, then it'll go towards the default route, or it might be a sense of learning where it will send it off to the next router if it doesn't pretty much know.
With a regular packet, correct?
Yes.
Excellent. Okay. So let me go ahead and call you a lifeline real quick. Kelvin, what's up, buddy?
Hey, what's up?
Hey, man. Sorry to bother you. I know you're cooking, multitasking. I just want you to, show some of your Cisco expertise. So, Kelvin, I'm gonna ask you this question.
Okay.
Same as Lamar, but it's gonna be, a little bit different. At layer 3, what do routers do with broadcast packets?
They drop them. Routers don't forward broadcast traffic.
There we go.
Okay. That's what you're looking for. Okay.
There we go. Make sense now?
Yep.
All good. So, Lamar, let's keep going. I like this. Let's keep going. So, right, is there something, and it's in your CCNA studies, since Kelvin, the other engineer, let us know that the router doesn't forward broadcast messages, is there something that we can configure on this router so that broadcast message from PC1 that's requesting an IP address from the DHCP server, that it'll forward that broadcast message regardless if it's a broadcast or not. Is there something that we can configure on R9?
So you're configuring it to be within that subnet for the traffic that's been sent.
Not exactly. What we're in layman's terms, what we're doing is there a way to configure on R9 to forward that DHCP Discover broadcast packet to the DHCP server so that PC1 can go ahead and get an IP address?
Yes.
Okay, what is it?
Yes. I'm not sure the exact answer you're looking for.
It's all good. It's all good, right? So Ramsey.
Yes.
Excellent.
I think it's
good question.
Yes, please.
No, go ahead. I'm sorry.
Okay. Yeah, I think the command on the router in order to get the broadcast packets to go to the DHCP server, which is outside the local area network, it would be DHCP IP helper, something like that.
Right.
Gotcha.
Excellent. And so, and Lamar, no, it's all good. It's all good. And what the router is then identified as, right, is a DHCP relay agent. Okay, because it's relaying that broadcast packet. It's turning it into a unicast packet, like a regular any other regular packet, and sending it to server 1. Okay.
Gotcha.
Make sense? All right.
Yep.
Let's go ahead and keep rolling. So, Ramsey.
You must have seen the steam pouring out of my ears. I just had a quick question about the source IP. I thought like there's a default like 169 or something like that, like not a loopback, but a default that's recognizable. Am I missing something?
No, you're thinking about
No,
HIPAA.
you're correct.
HIPAA.
You're thinking about just like Claude said, Microsoft's a HIPAA address. And what it does is it assigns that's their own software programming has to where if a PC doesn't have an IP address, as long as it's on the same LAN as another host that doesn't have an IP address, it can still communicate with one another.
That's
Old
right.
school Microsoft technology.
Gotcha.
Nobody knows why it's there, but that's one indicator letting us know a Windows PC doesn't have an IP address. Linux, it'll probably be different.
But isn't it like 169 or something like that?
Yeah, 169. And Brian, keep me honest here.
25.
Something like that. But yeah, it's 169. Yeah, something like that.
Yeah. Cool. I just wanted to put that in a box somewhere. So thank you.
But gentlemen, remember this: outside of the Microsoft world, that initial IP address and when you start thinking about the door process and you start digging into that Discover, that IP address is going to be quad zeros.
Copy. That's what I need to know.
So remember that if you ever get asked the question, what is the IP address of that first device that's trying to reach out to get that IP, that's trying to be a part of a network without Microsoft ever being involved, think quad zeros.
Thank you.
Amazing. Thanks, Claude. Appreciate you. Okay. So now back to the packet. So R9 has our packet. Ramsey, how does our packet look now before it's sent over to R8? What's the source MAC address?
Source MAC address will be, I want to say that it's going to be source. Okay, the source MAC address now is going to be the router 99 because it's going to go out of 99.
Okay, and the destination?
Will be the next router, which would be 88. Because routers do not hold on to information past the next network. I might be saying it funny.
Keep
Okay.
going.
Yes.
You're there, but keep going.
So routers only, in the routing table, only care about how they receive the traffic. And so it basically will just say, like the server 10.10.10, that traffic comes via router 9's gigabit 02 or 0/2. That's all it cares about.
Claude, help him out.
Okay, where's he stuck at?
So just explaining why the MAC address would be the MAC address of R8. Why do routers do that? Why did the MAC address change? By the way, Ramsey, you're correct. But you need to know why.
So basically we got a packet leaving out of R9 going to R8. So that's his directly connected network. That's his neighbor right there. So non knows about 8.
Mm-hmm. So Claude, it wouldn't be the MAC address of server 1?
No, we ain't got that far yet.
We ain't got that far yet. Excellent. Because, and guys, I just want you guys to listen to what Claude said. It's directly connected, okay? And Ramsey said a good nugget too. Routers, let's keep it simple. Routers are worried about layer 3, okay? And it only can control what it's directly connected to, going off of what Claude said, okay?
Yep.
So, excellent. Now, Jose.
Yes, sir.
What's that source IP address of the packet now?
Source IP, I believe it would be the one from router 9.
Yep.
Which one?
The one on gigabit 0/2.
Okay. Why?
Because it's coming out from that interface. I mean, I don't know, that's a pretty vague answer, but I mean, that's the cable that is connected to the router 8, and it will receive traffic like from that interface as well, coming from any of those, like coming from the server.
Okay. So Jose, so let's dig a little deeper on that. So let me just, and I think you know what the answer is, but let me throw this out there to you. What is the process of mapping layer 2 physical addresses to layer 3? What is that process?
I really don't remember right now.
Ramsey, I'm thinking you are thinking about it. Matter of fact, you even made a comment about it earlier in the process. What you thinking?
Address resolution protocol.
Are-
Am I getting extra credits or thrown off the boat?
No, you're good.
Yeah.
Thank you. And the camera helps so that I don't have any notes, keeps me honest.
No, it's all good. So Jose, let's walk through this, right?
Mm-hmm.
Me and you being an engineer trying to figure this out, right? Logically, if we're thinking logically, right, and just looking at this, you're absolutely correct. Logically, right?
Yes.
But part of your answer is incorrect, right? And let's take a look at this as me and you being the engineers. We make the IP address, right? We make the IP address the interface of gigabit 0/2, right? We send it over to server 1. The server 1 sends it back, and the packet is received on gigabit 0/2. It's never going to reach PC 1.
Oh, okay.
Does that logically make sense?
It does make sense.
It needs a way home.
Okay.
Yeah. Okay.
Right. And so just a refresher, guys, right? For everyone, right? What the DHCP relay agent does, right? Just like, I think somebody said it earlier, we're not just configuring, IP helper address or what have you, just for, on gigabit 0/1 for a reason. What we're doing is, right, what that does is whenever we go ahead and R9 gets ready to send that packet out, it's going to make it the IP address of that inside interface, okay? And within that DHCP packet, it's gonna have the MAC address of PC1, okay? That's the fun stuff about DHCP and combined with networking, okay?
Mhm.
That make sense?
It does.
Awesome.
Do you mind? I just kind of got lost in the weeds a second. Do you mind just saying that the DHCP relay agent? I just kind of missed that last part that you were saying.
No, no worries. And yeah,
Thanks,
just
David.
correct me and tell me if whatever you're missing. So yeah, so the DHCP relay agent, what it does is whenever it sends that, whenever it receives that DHCP Discover packet and the IP helper address command is configured on that inside interface, what it does is what's the word for it? It rewrites the packet so that the source IP address is an actual IP address that's configured on that interface because it needs a way home. If we send that 0.0.0.0 on the wire to server 1, it'll get there. It doesn't have a way back, just like you said, Randy. Okay, so that's just a technology with, the DHCP relay agent within itself. And I'm sure you guys seen it on your CCNA studies. If you haven't yet, you're gonna see it. So they're probably gonna ask you a question about it. I'm using these big terms that, I like to call them big terms because again, you're gonna have to know about it. And these, certification exams, they love to throw doozies, okay?
Mhm.
Awesome, Jose, excellent job. Lamar.
Yep.
So with that being said, right, what's our destination IP address gonna be?
Be the destination of the destination will be for the IP for router 8.
Why?
Because that's the direction in which the traffic is going.
Okay, logically, looking at the diagram and looking at a network, that would make sense, right? But but that's just like Jose. Let's dig deeper, right? Me and you being engineers, right?
Yep.
If that's the case, right, that DHCP packet that we sent out is R8, the DHCP server.
No.
Excellent. So if we send that and the destination IP address is R8, that packet is just gonna do what?
It's going to get dropped.
There we go. Absolutely. So with that being said, and with the knowledge you have now, Lamar, what's the destination IP address?
Oh, it would be the IP of the server 1.
Nice.
Sorry.
Guys, quick nugget within your CCNA studies and the real world. The source and destination IP, of course, DHCP is a unique situation. The source and destination IP will never change.
Yep.
Ever change. Ever. Okay? Per hop is referring to layer 2. That's what'll change every time.
And David, I think, and the only time the source and destination IP address will change, it's not really changing, is when the server actually sends information back to the PC, so that the source and destination will be swapped. So it'll be the same number, they'll just be swapped around.
Yep.
Excellent. Great job, Kel. Thank you, buddy.
Hey,
Thank
David,
you.
I got a question. I'm still a little confused about how at R9 the packet knows the destination IP address for the DHCP service can be 10.10.10.50. How does it know at that point that that's where the DHCP server is located at that IP address?
No, Carlos, that's a great question. I think I heard you correctly. How does the packet know how does R9 know or the DHCP relay agent know to make the IP address, the destination IP, the DHCP server? Is that correct?
Yes, that's correct. I'm sorry if I'm still muffled.
No, it's okay. I'm working it out. It's all good. So, right, back to what Ramsey stated, right? What we're configuring, right? We're configuring the IP helper address on the inside interface, gigabit 0/1, right? What we're doing there, we're putting the IP address of the DHCP server and what's happening in the background, right? When me and you were talking earlier, right, Carlos and Jose, whenever that DHCP Discover message is sent out on the wire, that IP helper address of the DHCP server is responding to that DHCP Discover message. Okay?
Okay.
Because if that broadcast message is sent out without the IP helper address being configured on R9, just like Kelvin was saying, it's going to get exactly, Lamar, exactly. It's going to get dropped. So us configuring IP helper address, it responds to that broadcast on that local area network to then go ahead and be able to forward that packet. Okay? Did that help out?
Yeah, most definitely. Yeah, that makes sense now. Okay.
Turns it to a unicast. But
there we go.
The server one
That was
IP address, the server one IP address, wouldn't that be in the routing table for R9? Would that be an answer as well?
But see, here's the thing, fellas. Here's the thing.
Thank you.
When it passes through those, and we'll call them layer 3 devices, you know, when you were reading, you were hearing about encapsulation, decapsulation, basically is stripping away. If I get something at layer 3 and it's not for me, I don't need it anymore. It's there's no need for me to touch it no further. Okay, so
unless it's acting as a layer 2 device as well.
Unless it's acting as a layer 2, but the thing is,
there we go.
The thing now is, if I get a packet and I strip it down and realize, first of all, this IP isn't even to me. It's not to me. So I need to keep pushing this on, you know, in the direction based off the tables, based off of the direct connected neighbors, all that good stuff. This isn't for me. So I'm going to push this on further down the line because this is not my IP that is trying. So there's no need for me to read this. Does that make sense? So keep that in mind when you're looking at the decapsulation and encapsulation. You know, when you're going through that OSI model, just remember, does a specific device really have a reason to open this up? If not, let's keep it moving. Does that make sense? My bad, Dave. My bad, Dave.
Oh, Claude, please. No, this is good. We're just talking about theory now. I think that was a great way to keep it simple. Telling you guys, we're gonna keep it simple, you know, and we're gonna, you know, and that's why we have Claude here, we got Kelvin here, we got Brian here. I'm gonna go probably in depth from the OCG. The other folks here are gonna keep it simple. I'm gonna try to, you know, keep it as simple as possible, but again, I want you guys to be successful engineers, not just with a CCNA, but beyond that, okay? All right. So awesome job, awesome question. That's great. So Lamar, you're my best homie right now. Okay? So
Gotcha.
R8 gets the packet. All right? R8 gets the packet. And I believe you because I feel like the gears are turning for you now. R8 gets the packet. What does the packet look like now?
You're referring to it the gigabit Ethernet. I mean the gigabit interface 02.
No, I'm glad you said that. Let me reword my question. Now that R8 received the packet, right, and wants to send it to server 1, what is our packet going to look like before it sends it out on the wire towards switch 3?
Oh, on the other side, on 00. Okay. So the source MAC is going to be the MAC of the router.
Okay. And guys, I'm keeping it. And Lamar, you're right, by the way. I'm keeping this topology simple, but in the real world, it would be the MAC address of that interface. Okay.
Yes.
Okay.
Because it could be multiple MACs depending on which interface you use. Yep.
There we go. Excellent. Excellent. And what's that destination MAC address, buddy?
So it's going to afford it to that nearest layer 2 device, which would be the
Okay.
MAC address of switch 3, would be 33.
Excellent. And what's that source IP address?
And it'll be from the IP address of the router on the gigabit 00.
So it's going to change to this.
Yes, sir.
Okay. So, Lamar, remember what we said, right? Rule of thumb. The MAC addresses, in most case scenarios, the MAC addresses will always change on a per hop basis.
Well,
The
yes,
source
yes,
and destination IP address will never change.
yes. Yeah, no, it would be for PC1. Sorry about that.
No, no worries, no worries. And not so much PC1, but it'll be the IP address of R9 inside interface, right?
Yeah, because that's where it's coming from.
Right, and it needs a way back, just like Ramsey was saying, correct?
Yep.
Awesome, awesome. And what about the destination IP address? Will that change?
No. It'll still be for server 1.
Awesome, great. Okay, so what we're gonna do, we're gonna take a back seat. We're gonna go ahead and leave this little packet right here, okay? Switch 3 has it, right? And what we're gonna do, we're gonna take a little, drive down spanning tree lane, okay? We're gonna go ahead and identify the path that switch 3 is gonna take to go ahead and send this to server 1. Ramsey,
Hit me.
who's the root bridge?
The lowest MAC address. So it's the bridge ID. So if it has the default, 32764, I think it's something like that. If that's the default, then it goes to the MAC address. And the lowest MAC address looks like switch 2 of 2s. So that would be the root bridge.
Good deal.
Excellent. Okay, excellent. So with that being said, can you identify the port states and roles for me on switch 2?
The designated ports would be the ones connected to switch. Okay, so here's where I always have to take a step back. So my default answer is on the root bridge, all of its ports will be designated ports, but because they're so slow, those will probably not be preferred. And so the gigabit 00 interface on switch 2 will be designated, just kind of tracking it along. And then to switch 6, gig 00 on switch 6, that'll be the root port. Is that what you want me to spell it out?
No, nope, we're just talking about switch 2. What's the port states and roles?
Okay. Gig 00 is going to be designated. And then I feel like gig 10 will be, I have to take a pause. Are we doing STP or RSTP or PVSTP?
just regular STP.
Standard.
Regular.
Yeah.
Copy that. Yep. So
you
it's not hogs, it's blocking.
Think about it. Think about it. This is your root bridge. This is the top of the tree. Okay.
Right. So it has to be designated.
Mm-hmm.
Okay. That's the best way for me to know. Thank you.
Awesome.
Oh, because it just gets blocked at the other end?
There you go. That's where the
Copy that.
ain't no blocking going to happen at the end. Yeah. You got it.
Because think about it, right?
Yeah, I saw it click in his face on the video. Yeah.
Yeah, I saw it. Look, I was just gonna let him keep talking. I was like, you're there, but you're making yourself stuck, right? So think about it. Let's talk about just a tree, right? the root is at the bottom of it, and the tree flourishes, right, from the root. If we stop the tree from growing, how the hell is it going to become a tree? That makes sense? Logically, right? Makes sense, guys? Everybody?
Oh, yeah, it does.
Excellent, excellent. So again,
Mhm.
the port role is going to be designated, right? From the root. Okay? I'll put that there, and we know that. That's there, perfect. And of course, the port state is going to be what, Ramsey? Let's finish it.
Active, is that the right word?
Forwarding, right? So it's either
Forwarding,
or
yes.
block. It's either
Yep, that's right.
forwarding or
Yep,
blocking.
forwarding. Thank you.
Right? No worries, no worries. All good. Okay, perfect.
Can
Now-
I just do a quick question of, on the CCNA, do we have any idea which one they're going for? I just feel like it might not be STP, but it doesn't matter.
No, that's a good question. So back to what Claude said, it doesn't matter. It's just straight up gonna, STP is STP, no matter what enhancement, either RSTP, PVST is gonna work the same. It's gonna just be little enhancements. So you gotta know how to do that, okay? Make sense?
Yeah, great way to build.
Perfect, perfect. Okay. Whew. Carlos,
Yes, sir.
switch 5. What I want you to do, I want you to go ahead and tell me what'll be the port states and roles for all of its interfaces and explain why. And if you don't know, it's okay. Here to help you.
On port 5, since they're all gigabit interfaces, well, they have different speeds, never mind. The gig 02 will be the designated port, and gig 00 and 03 will be set to forward or blocking.
Okay.
Carlos, let me give you a little help here.
Sure.
So we've identified the root bridge, right? Let
Okay.
me ask you this. Since we know that the root bridge is the end all be all, every switch that's in a topology has a link that is, for the lack of a better term, going to be directly connected, or I should say the path, the direction to the root bridge. Do you know what that port is called?
Oh, yeah, I know it.
Okay, how about this? How about we phone a friend? I see Mr. Anderson. I'm gonna get my matrix mode. Mr. Anderson.
Mr. Anderson. Yeah, you can see me all eager over here. That's why I keep the camera on. You guys can see what I'm up to. But yeah, there's a great T-shirt that says "I am root." You know, like I'm trying to think of like the best way of bringing it. So there's a designated on one side. Do you know what the other side is?
But just help him out
Root.
with that.
Yeah. So
yeah.
You
one
have
port.
designated on one side and you have root on the other. And so what I do is I always start at the root bridge because I know those are designated. And then it's like leapfrog. So
Okay, hold on.
designated root.
So let me slow you down. So Carlos,
Yeah.
did you catch what he said? What that one port is that has that path back to the root bridge?
Designated port.
It's a root port.
Oh, root port. Okay.
Have you heard
Yeah,
of that one?
yeah. I did.
Okay. Now check this out. We all know that all switches got a root port, right? But
Mhm.
how is it determined that root port is selected? Think about that for a minute.
Isn't it the
Because see, here's the thing.
Isn't it based off of speed of the actual
Okay.
interface?
Okay.
Or
Okay.
like
Let's
a
elaborate a little
priority?
bit deeper.
Sorry.
Let's elaborate a little bit deeper. So the speeds do have somewhat of an effect, but more importantly, what is the speed going to dictate?
The cost value or the
Boom, boom.
yeah.
There we go. There we go. That's
Yeah.
what I was waiting for. That's
It's been a while, guys. Sorry.
It's cool.
okay.
It's cool.
Okay.
It's cool.
It's cool. It's cool. This is why we're here. Keep going. Claude, go ahead. Keep rolling with them.
Okay. So you're talking about the cost. Okay. Is it a high cost? Is it a low cost to get back to the root bridge? You tell me.
A low cost.
Wonderful. Wonderful.
Bingo. Excellent. Let's keep
Okay.
going. Let's keep going, Carlos. You're on it. You're on it. Keep going.
All right.
Claude, keep going with him.
So down there on that switch number 5, we got 3 ports, 02, 00, and 03. Do some quick math in your head, okay, and determine which one of those links has the smallest cost back to the root bridge. Now, don't get this, because see, this is where some people can really get jammed up because they think that, oh, well, this here link is 1 hop, okay? And you can get jammed up thinking like that.
Yeah,
because
that's where I was getting stuck at. I was
yeah,
like, well, it's less hot.
Very easy to.
yeah, that one link might seem to be the shortest path, which is that now you're going down the OSPF world where you start talking about that. Okay,
Yeah.
but when we back it up here in the spanning tree, sometimes that shortest path may not be the best path based off of cost calculations. Okay.
Okay.
So I don't know if you remember this off the top of your head, but there's a cost associated with a 10 meg link, a 100 meg link, and 1,000 meg link, a 1 gig link. You happen to know those costs off the top of your head?
Not off the top of my head, but I do know that.
Okay. Okay. All right. So let's do this. I'm gonna tell you these here figures, and Dave or anybody else, keep me honest. A 10 meg link being the slowest, you're looking at a cost of basically 100.
Yep.
Okay. A 100 meg link, you're looking at the cost of 19. Okay. And the 1 gig or 1,000 meg link, you're looking at a cost of 4. Okay. So with that in mind, you have to you got your thumb on the Mac on the root bridge itself. Now, with that in mind, with those costs that's associated with those given speeds, you can literally do it path by path and and add them up in your head or your calculator or your fingers and toes, and if you want to, and make note. If I go this way, I got this link, I got that link, I got this link, that link. Add all the numbers up, and you got a cost. And if you go this way, I got this link, and this link right here, and you got a cost. And then you say to yourself, if I go this last route right here, this link, I got this cost, that cost, and this cost. And what you do is now you got 3 pieces of information to make a decision on. Okay. You got 3 pieces of information to make a decision on. And when you make that decision should be based on the lowest number that you just calculated. And that's going to be where your root path, your root port is going to be placed. Does that make sense?
Yeah, it does. Okay.
Perfect break. Claude, that was an excellent breakdown. Carlos, does that make sense?
Yes, it does. It does.
Awesome. So Claude, if you don't mind, can you and Carlos walk through each link and compare the cost and see which one will be chosen as the root port on switch 5? If you guys don't mind. If you guys don't mind.
Yeah.
And
So
what I'll I'll annotate, of course. I'll still annotate the the diagram, what have you. Okay.
Okay. Okay. All right. So Carlos, you still with me?
Yes, I'm sure. Yeah.
All right. So let's just for giggles, let's start with the gig 03 down there on switch 5.
Mhm.
Okay. All right. What kind of link? What's that link speed we got on that?
It's a 10 meg link.
10 meg link. Okay. So let me get my pencil and paper out because all right. So we got, what is the cost associated with that 10 meg link?
100.
Exactly. All right. So we keep that in mind, right? All right. Let's go on over to the gig 00 link. All right. What's the first link that we got associated with getting to the root bridge?
It's going to be 100 meg link. Cost is going to be 19.
Okay, so that's 19 going up to switch number 6, right? So let me write
Mhm.
that down. Let me write that down right there. Plus, okay, so we at root switch. We ain't finished with the marathon yet. So from root switch from switch 6, where do we go to get to the root bridge?
Gig 00.
Okay, and what link speed do we got associated with that one?
It's a 4. It's cost of 4, which is gig 00 on that.
Okay.
On that.
So here's the thing. We got to take a look at the total cost of our egress. Okay. So you already told me we got 19 from switch 5 going to switch 6, correct?
Yes.
Okay, now let's take that right-hand turn, right? And we got 4, a cost of 4 going from switch 6 to the root bridge, which gives us a total of what?
23.
Okay. All right. So we got 2 costs already. We got the gig 03 with 100, and we got gig 00 with 23. Okay. Now we got the last one, gig 02. Right. So for us to go gig 02,
You have to go all the way around.
mm-hmm.
Yeah.
So let's just for giggles, let's go ahead and go to switch 3. What kind of speed we got associated there?
We have 1,000 meg
Okay.
circuit, and it's going to be a cost of 4.
Okay, so we got 4 right there. All right. Now here we go. We at this here junction of the road right here. We can go 2 different ways. Now that we have switch 3. Okay. But mathematically, we already know in our minds we can choose between a 10 meg and 100 meg, right? Now we know that the 10 meg link, that's going to be 100 right off the gate, right out the gate. You get that?
Yeah, I do.
So that 100 meg link, what kind of cost we got associated with that?
It's going to be 19.
Okay, so we got 4 plus 19. All right, so now we back at switch 6 again. And then at switch 6, you get to the root, we looking at what? Another
4.
Another 4.
Yeah.
So there we looking at 23 plus 4, we're looking at 27.
So your report's going to be 00.
Exactly.
Switch 05. Yeah.
Exactly. Which is going to make that other end, which Mr. Anderson was talking about, is going to be a designated port on the other end. Does that make sense?
What do you mean on the other end? I'm trying to
switch 6. So you identified the root port on switch 5 being 00. Am I correct?
Yes.
Okay. And that's what David wanted you to do. He wanted you to identify what that root port was. And now that you know how to identify a root port on a given switch, and it's based on that cost back to the root bridge. Is that all? Did that all come together for you?
Yes, it did.
Okay. Excellent. Sorry about that, Dave.
Please don't ever apologize. That was excellent.
I really appreciate that. That was good. Thanks, guys.
Did that make sense, everybody?
Yeah, root port always points back home, or points to the root.
Points back home. There you go. I like that.
Okay. And Carlos, we're going to keep going. I want you to stay on this switch because everybody's going to get a switch of their own to go ahead and convert. Okay. So you said gigabit. Which gigabit is your designated on switch 5?
0.
You said 0.
Yeah, 0 is the one that. Oh, designated.
Yeah, that's your root.
Oh, sorry. I
Yeah.
got confused. It's going to
No, it's
be
all good.
002 and 03.
Okay. And what's going to be the status of gigabit 0/3?
It's going to be probably in blocking.
Okay. Do you have all the information you need currently in the topology to make that determination?
No, I do not.
It's okay. It's okay. So excellent. So I want you to hang on to that. Okay. So now, right, Lamar.
Yes, sir.
Still with us?
Yep.
Still with us?
Yep.
All right. All good. So with that being said, and again, you can call on Claude to be a lifeline. I want you to go ahead and do the same thing for switch 6. Okay. Identify the root port and identify your other ports.
Okay. 1 second.
Take your time. Take your time.
So a root port is coming. I can't really see which interface that is, but it's the closest to the root. This is on switch 6. I can't see what's the nomenclature for that gigabit. Yeah, that one right there. Yep. So 00. That would be the root port.
Okay. Why?
Because of the cost that it generates with that particular speed is 4 to get back to the root bridge.
Compared to all the other speeds, what are the other speeds of the other links? Will the
So
other
it's
links be
like
better or
basically
no?
100 will basically give me 1 second. Yeah, 100 would generate 19 costs. And that's for gigabit 02 and 03.
Perfect. Perfect. Kept it simple. I like that. Claude, any objections? All good?
All good. All good.
Perfect. Okay. So this is our root port, right? Is that what you told us, Lamar?
Yes.
Perfect. We're going to take a step back and we're going to go ahead and I want you to go ahead and you're going to work together with Carlos, okay?
Mhm.
And I want you to work on, and I'm going to draw something, and I want you guys to work on this and think of spanning tree as this moving forward. Where is it? My favorite color. I got my favorite color here. Perfect. That's fine.
Is it purple?
Here's it.
Green.
Is it red?
Close.
Is it red?
Close. Close. No, it's green, dude. It's green.
Oh, that's bad.
All right.
That's bad color.
Green's money, so you can't hate on it.
So guys, okay, we're going over this, right? For a reason, right? I know you guys seen on LinkedIn these huge topologies, probably what I've just posted last week. But the thing about spanning tree, it's so simple. Once you know the art of how to, converge it just with words and a piece of paper. Once you know how to do that, you'll be so powerful. And one of the key things I want to show you guys is I want you to look at spanning trees always via a triangle, okay? Via a triangle, redundant links, okay? Redundant links. If we have switch 2 connected to switch 6, that's one link. We have switch 6 connected to switch 5, that's one link. But then when switch 5 connects to switch 2, now we have a redundant topology, because if the link between switch 5 and switch 6 go down, Lamar, can switch 5 still communicate with switch 6 if the link between them go down?
No.
If they have a link between switch 2,
Wait, I'm sorry. Could you repeat that again?
no, sure. So we have links between switch 2, switch 6, and switch 5. If the link between switch 6 and switch 5 go down, can switch 5 still communicate with switch 6?
No. No. Well, I
It
mean,
can.
it depends on the. I guess. Yeah, it can via
Goes a
like
long way,
the root
right?
bridge. Yeah.
So it will have an
And not just
alternate port.
not just with the root bridge, right? Guys, let's keep it simple. Forget all the terms, right? It
Yep.
has another link towards switch
It would,
6.
so it
via
would just
switch
take the
2.
next best route, right?
Yeah, it'll take the best. Yeah, the best
Got it.
path to do it. Okay.
Guys, get the hell out of the book. Stop it. Keep it simple. I'm keep it simple. It has a link. It has a connection to switch 2 from switch 5, okay? And there's a connection from switch 2 to switch 6. And there's a connection from switch 6 to switch 5. The triangle that I made, if this triangle, let me go ahead and help you out here. If this goes down, can switch 5 still reach switch 6?
Yes.
Yes.
There we go.
Yep.
Okay. So all Spanish trees job, right? And it's one of the major functions. And please take note. Feel free to. One of the 3 major functions of the switch is spanning tree to prevent loops on a redundant topology. Okay.
Yep.
So
Yep.
I want you to remember that. So with that being said, guys, Carlos and Lamar, you guys are going to work together to converge this triangle right here. Okay. All right.
Yep.
So Lamar, okay, and guys, Carlos and Lamar, you guys can use Claude as a lifeline. Just call them if you can, if you want to. Okay. So we haven't identified on switch 6, the other port, what that port role and state will be, nor on switch 5, we haven't identified what that port state and role will be. Let's go ahead and work that out. Claude, you want to help him?
Okay, so switch 5, that's is that Carlos's switch?
Yeah, switch 5 is Carlos's switch.
Yeah.
Okay, so Carlos was waiting on some more information. Am I correct?
That's correct.
Okay, so switch 6 was Lamar, right?
Correct.
Okay, so Lamar, so you've identified your root port, right? Now let me ask you this, because you're looking at it right now with the root port that you identified. If you have a root port and as Mr. Anderson says, that is your way back home, what is on the other side of a root port?
The designated.
Okay, so with that piece of information, Carlos, you've identified your root port.
Yes.
What's on the other side of your root port on switch 6?
Designated port.
You asking me or you telling me? I'm gonna get like Dave now.
I'm telling you it's a designated
Okay.
port. Yes.
Okay. All right. Dave, did you catch that?
I did catch it. Let's bring it home.
Okay.
Let's
Okay.
bring it home.
So now that you have your root port identified, your designated ports identified, still working on that same triangle that he identified earlier, switch 6, the root bridge, and switch 5.
Yep.
Where does that leave us to block at so that we will not have a loop?
At 0-3.
Exactly.
Mm-hmm.
Why? Anybody? Why?
It stops the loop.
Plain and simple.
Okay.
Yeah.
Simple as that. Simple as that. That makes sense, everybody?
Yes, sir.
Awesome.
Yes, it
Yep.
does.
That's how
Sure.
you convert spanning tree by hand.
Okay.
And it's scalable. It doesn't matter how big the topology is. You always just start with your root bridge.
Keep it,
That's the
yeah,
good part.
exactly. Keep it simple. Look at whenever you guys see these topologies, on LinkedIn, don't get discouraged. Treat each redundant link, right, as a triangle. Keep it simple. Then you're gonna look at these topologies like the Superman one that I posted. You guys are gonna look like, oh, it's not that bad. I just have to consider the link speed. Now, that's it. Okay, perfect. Where am I at? Okay, Jose,
Yes, sir. I'm here.
what's up, buddy? You ready?
Yeah, he ready. He got it all down now. He ready.
Oh my God.
He gonna look like a superstar spitting out the root port, designated port. Why? Let's block this. He gonna look like a superstar now.
So how many root ports you guys want? Oh God.
All right, Jose.
Yes, sir.
You know the name of the game. You know the name of the game. You have Claude as your lifeline. Go
Okay.
ahead
I tell you
and
what,
convert
is the 1, 2, 3, 4. Okay, I'm just looking at the participating list. I'm looking at the names. That's all.
Oh, gotcha. Okay. Okay,
All right.
Carlos, Jose, it's all you. Remember, guys, you have to explain why. Okay, so I'm gonna challenge you every time to explain why of your decision. So feel free to take your time before answering.
Okay. So what's the question?
So no, and I'll feel free to say it again. I want you to identify on the switch that I gave you for each interface the port states and the port role.
Okay. And my switch is, I'm sorry, it cut off when you were saying that question.
No worries. No worries at all. My apologies. It's switch 3 is your switch.
Switch 3. Okay. All right. So let's start with the root bridge. Root bridge will be gigabit interface 0/3. And that's because it's the cost to get to the root bridge. So that would be.
So you're saying gigabit 0/3 is the root port, correct?
Yes, sir. It has the lowest cost to get to the root bridge. Yeah.
Okay. And what's the cost of this link to get to the root?
So that would be a cost of 19 plus 4. So that's
Okay,
23.
Give me one second. I want you to walk me through it. So from here to here, what's the cost?
That's 19.
Okay. And from here to, you say here or here?
We will go straight. Yeah, we'll go all the way straight. Yeah, because that's
Okay.
I mean, just by looking at it, the link going from switch 5 to switch 2 is at 10 megabytes, so that will add 100 right off the bat. And
Nice. Okay, keep going.
so I will say it will go from switch 3 to switch 6, and from switch 6 to switch 2.
Perfect. Okay.
Yeah. So that will be the root port. Let me see. For the designated ports, I think the designated port will be gigabit 0/2 on switch 3.
Okay. Why?
Let's see. Does the cost has to deal with the choice of the designated port?
You're asking me, you're telling me.
I'm asking.
Okay. So Claude is your lifeline. So go ahead and ask him. Claude, you want to help him out?
Oh yeah, help me out on this one.
It's all good. It's all good. You're doing good, by the way. You're doing good, by the way.
Okay. Where you stuck at? Where you stuck at?
So we found that root port, and so from the other two ports, one is going to be a designated port and the other one will be blocking, right?
Okay.
So my question is for me to pick for switch 3 to pick the designated port.
Mm-hmm.
Yeah, counts the speeds of the links.
The cost associated with them.
Okay. Well, in that case, I believe the designated port will be the one that I picked because the cost is extremely low compared to the other one. Because let's say to use gigabit 0/1, that's 100. And if it goes from the top, from switch 4, if you use 1/0, that's another 100. So yeah, I think I think the gigabit, I cannot see the number of the interface, but the one going to switch 5 will be the designated port.
And what's that total cost?
The total cost, that's 423 and 27.
Okay.
Yeah.
And so this way wouldn't work. It wouldn't work.
Oh, it would not work. Yeah, that's 200 right there.
What about this way? From switch 5 to switch 6, this wouldn't work.
That wouldn't work either. That's
Really?
Yeah, let me see here. Yeah, it wouldn't. I don't think it will work.
Why?
So okay.
All right, man.
All right.
Hey, you doing good, man.
You're doing excellent, by the way. Again, I want you. The reason why I'm challenging you guys to explain why, because when you're on the exam, you have to convince yourself why. Okay. Take your time, Carlos. Jose, sorry.
It's just tying the puzzle pieces together.
Yeah, looking at cost.
Did we lose Jose?
Oh goodness,
I think he's on mute.
I was talking all this time. My bad.
Yeah.
Oh my God.
It's all good. It's all good. It's all good. It's all good.
All right, so okay, I will start over. So let's take the bottom path from switch 3. So if we use the bottom path from switch 3, we get to switch 4. I mean to switch 5. That's a cost of 4, right? The switch 5 would not like going straight to switch 2 because that would add a cost of 100 right there.
What's another reason why I wouldn't go to switch 2?
Because
you're right.
It's a blocking. I see that.
Exactly.
It would open itself up for a loop if it did that.
Exactly. Perfect.
Hey.
So Carlos and Lamar already took care of it. Yeah, can you hear me?
Oh yeah, my connection went out for a second.
No, it's all good. It's all good. So you explained it perfectly and kept it simple.
Mm-hmm.
It's already blocking here.
Mm-hmm.
How, even if we could, how could it get to switch 2? It can't, right?
Okay.
It can't. Carlos and Lamar already determined, hey, we're just going to go ahead and block this one, okay? Because that's not the fastest path to the root bridge. Okay.
Yeah. So yeah, we will want to go up, and that would add a cost of 19. So
perfect.
So from here, we can take the right path by going directly to switch 2. it has a cost of only 4. Opposed to taking the long route that it will add a cost of 119.
Perfect. Perfect. Awesome. We're not going to do gigabit 0/1 yet because we need to go ahead and converge switch 4, okay?
Mm-hmm.
Patrick, how you doing?
Doing good, good.
What's up, buddy? You ready?
I have a good question before we move forward. So
Sure.
on switch 3, since we found the root port and the designated, the gigabit 0/1, that will go into a blocking state?
Not necessarily. And that's a great question.
Mm-hmm.
Not necessarily. Okay. So it all depends on the topology, right? Because we may have a designated switch within the entire segment that's a non-root switch, and say, hey, I'm not causing a loop. I can, I may not be the root bridge, but I can forward on all of my interfaces based on the, the communication I've done with the different switches.
Okay.
Okay. So just putting a switch that's not the root in the blocking, you don't have to necessarily do that. It all depends on that triangle, to keep it simple.
Okay.
Make sense?
Makes sense. Thank you.
No problem. Claude, you want to provide any insight? Kelvin, any insight?
No, you nailed it. From what I heard, yeah, you nailed it.
Cool. Kelvin, I'm all good.
All right, look, it makes
Kelvin's
sense.
Kelvin's cooking dinner. He got to be. All right. Excellent.
Yep, my bad, man.
So,
I did kids, I got put in the bed.
it's all good, brother. It's all good. But all good, Kelvin?
Yeah.
Spot on? Awesome. Okay, perfect. So, Patrick.
Yes, sir.
Switch 4. Same as before. Same as everybody. I want you to let us know the port state and port roles for each port on switch 4. And Claude is your lifeline, so he can help you. Okay.
All right. Cool.
Feel free to take your time. Okay.
All right. Cool. All right. So based on the topology, and you said switch 4, I'm seeing that gigabit port 0/2 looks like it's going to be the root port due to the fact that it's 100 megabits link, and that is going to give me it's going to be 19 plus 4, which is going to give me 23 to get to switch 2, which looked like that's the shortest path or the lowest cost to get there. And let me next port 10, 100, 119, 123. So that wouldn't make sense. All right. So from what it looks like here, the next path, the next option would be, I'm going to say the designated port would be, no, I'm sorry. Yeah, I guess the designated port would be a gigabit 1/0. The path, it looks like, okay, it'll be 100. The cost would be 100 to get directly there to switch 2. But looking at port 0/1, it will have to go traverse. It'll be that same cost of 100. So that automatically would take it out as far as it being a designated port, which will leave it in a blocking state.
All right, so you're saying that you want to block on gig 0/1 that goes to switch 3?
Yeah, because it doesn't.
And
I'm sorry.
And guys, remember, Patrick, you have to converse with Jose, because Jose is the owner of Switch 3. So you guys are going to talk amongst each other to see who's going to be blocking. or
Right.
if blocking needs to happen or not.
Okay.
So I'll let you guys talk with that, amongst yourselves and with Claude.
All right. So from how I'm looking at it, my port 0/1, if I go from there to his 0/1, it's gonna be the same cost for me to get right to the, to get to switch 2. So that would be going like back door way. It looks like he already has his root port and his designated port. So it doesn't look like there will be any need for him to push traffic through that way at all, unless we're looking obviously like at a redundant link, which we're trying to avoid with the spanning tree protocol. So that's my outlook. I don't see any reason for me to push traffic through that route. And it doesn't look like he is using it either, because he already has confirmed his root port and his designated port.
Okay. So Patrick, let me ask you this.
Yeah.
You've identified 02 as your root, correct?
Yeah.
Okay. Who's the owner of number 6?
I am Lamar.
Okay. So Patrick,
Mhm.
what's on the other end of that root port connection?
The other end,
Yeah.
as in going to switch 6.
Going to switch 6, right?
That should be also. Is that also a designated?
We don't have nothing there.
Yeah, we haven't gotten there yet.
Uh-huh.
So you're gonna
So
have to talk with Lamar.
okay, all right. So can you go here? So what do you think, Lamar? Because you have a designated root port. We're gonna do the triangle, okay?
Mm-hmm.
Remember that root port is the way home.
So
Right.
I wouldn't me personally, I wouldn't recommend blocking at my interfaces for 02, because that is the way home.
For me, yeah, for sure.
Yeah.
So okay.
But okay, go ahead. I'm listening.
No, Patrick, go ahead. What were you about to say?
Because yeah, he's gonna if we do that, if he block me, I won't be able to go home, or I would have to use that. I would be forced to use that designated port or that alternate port of I don't know. I think I can't see it's on there, but I'll have to use a 10 gigabit link that goes directly to switch 2. So
The switch 2, right at that first interface.
yeah,
That's 10.
so
By
10. So I wouldn't, unless I would have to go to 10. But from what I'm seeing here, the best route or the shortest path, and in that sense, would be lowest cost. I think to go to 02 would be good. So that port itself should also be a designated port.
So guys, let me step in here, okay? Let me go ahead and step in. So we have a root bridge and we have non-root bridges, correct?
Mm-hmm.
Okay. So we have, within that triangle, we have something called a designated switch. Okay. So we have a little triangle right here. Correct?
Yep.
Okay, perfect. So with that, right, the election process, right? Anybody know the election process of a designated switch?
Is it the priority ID or the root ID?
Close. So
sorry.
No, you're close. You're close. I'm glad you're thinking about it, right? So it's the switch with the lowest cost to the root, the lowest cost home.
Yep.
Okay. So Lamar,
Yes, sir.
between you and Patrick's switch 4 and switch 6, who has the lowest cost to the root?
Between switch 4 and switch 2? Is that what you're asking?
No, between switch 4 and switch 6. If I had to compare, hold on. If I had to compare this link and this link, who has the lowest cost?
Oh yeah, switch 6.
Perfect.
Yeah, that'd be cost of 4.
Well, you said most cost, but we knew lowest cost, right?
Yeah, excellent. I apologize.
I might have misunderstood. But
My
yeah.
apologies. Yeah,
Wait.
Thank you for keeping me honest. Thank you. It's all good. So lowest, right? So now that we identified which one has the lowest cost, switch 6 is going to be the designated switch.
Yep.
What does that mean, right? What does that? I mean, that's a big word, but what does that mean? That means, right, in the
There's a
selection
blocking
process
word.
of blocking, right?
Wait, I didn't hear that. What'd you say?
Who didn't hear that? I'm sorry.
Lamar.
Yeah.
Lamar? Okay. Lamar,
Yeah.
my apologies, right? So since we identified, right, your switch has the lowest cost to the root, if it, compares itself to switch 4, right?
Mm-hmm.
Switch 6 is going to become the designated switch for this triangle, okay?
Yep.
All right? And
Yep.
what that means, right? This means we're going to be forwarding on this link. Guess what we're going to do, Patrick?
Yep.
Guess what we got to do, Patrick?
What we would have to do in regards to forwarding
Port
on.
states and port roles.
I'm sorry. What we would have to do as far as which port?
So what are you going to have to do now with your port states and port roles? Now that we identified that switch 6 won the election and is the designated switch.
Yeah,
So now we have a loop.
Yeah, because right now your switches are locking up on you, and you're not sure what's happening.
Yeah. Okay.
So Patrick, this is your switch 4. What are we going to do to fix this loop?
I need to block that port 10 to stop it because it's causing a redundant. It's a loop, as far as both of them are going to root, so it's going to end up being an endless loop. So I would need to go ahead and stop one of them, and the one that one is my root port of 0, I believe. I'm sorry, I don't know what one, but the one that's connected to switch 6. So that one has the low.
That's going to be your root, or it's going to be your root port.
Yeah, well, we identified the root port, so that the designated port, I guess, will be we'll change it to put it in a block state to stop the loop.
We're gonna block on the root port. Is that what you're telling me?
No. On gig 1/0, we're gonna block that. We're gonna block that one, the one to the right.
Okay. Why?
To stop the loop. Because let me see here. Yeah, because it's another option to get there to root, and because it's a redundancy because I can go to switch from my switch to switch 6 to switch 2, which is the lowest cost, and I can also get there by going to switch.
Stop right there. Keep it simple. Don't go in a rabbit hole. We just elected our designated switch. What's our lowest cost to get home? Is it through the 10 meg link or the 100 meg link? We just identified it.
So it'll be the 100.
Keep it simple, okay?
Mm-hmm.
All right. And guys, I'm not saying this to be mean. I'm saying this so you guys don't kill yourself with test anxiety, and of course when you guys get into the field. Keep it simple, guys. Keep it simple, okay? So, again, great job, Lamar and Patrick. So we're going to go ahead and block on this one, correct?
Yes.
Perfect. Perfect. Now, oops, sorry. Here we go. Okay, excellent. So, with that being said, now, and I believe, and correct me if I'm wrong, guys, who's switch 3? Who owns that switch?
Not it.
Jose or
Yeah, that's
Carlos?
me, switch
Okay, perfect. Okay. So, Patrick, so with that being said, what's going to be your port state and role for gigabit 0/1?
That one should be
Because we still have to include Lamar, because we still have a link between switch 3 and switch 6 that isn't identified.
Yep.
yeah. Should it? Would that be a designated port though? I'm gonna go with designated port. I can't even give you an exact reason why. Let me just think it through.
Nope. Use your lifeline.
Okay.
Claude is your lifeline, guys. So you saying you can't think about it. You have fellow engineers. And guys, this is a big point. Let me make. You are never by yourself. It is very okay to ask for help. Okay.
Okay. Yeah.
So,
definitely I'm gonna have to call on my lifeline for this one to
perfect.
help me.
Okay, my phone's ringing at 3:30 in the morning. What's the problem? what you trying to figure out?
All right.
Start with some pleasantries. Good morning.
Yeah, exactly.
Good morning. Well, sorry to wake you. But it looks like I'm having an issue with identifying the port as far as like the port state of gigabit 0/1 on switch 4. We've identified the root port and the alternate port / blocking port.
Mm-hmm.
And we have this one last port here that's connected to switch 3, which we haven't also identified as if it's what state that port is as well.
Okay, so currently you have which ports identified?
I got I can't see the 2 there.
Okay, just tell me what they identified as. You don't got to give me the port.
Oh, okay.
Numbers.
Root port, and blocking.
So you got a root port and you got a blocking port on switch 3 is what you're telling me?
Or alternate port, yeah. So, it's an alternate.
Are you on switch 3 or what you on switch 4?
I am switch 4.
You're switch 4. Okay.
Yeah.
All right. Okay. So let's do this. We're always going to have a designated port on a given segment. Okay.
Mm-hmm.
So you've already identified a root port. You've already identified an alternate port. So this leaves us one last connection.
Mm-hmm.
And what do you think that connection is going to be?
Designated port.
Mm-hmm.
Okay. Got it. So designated port.
And what port is that going to be on?
Gigabit Ethernet 0/1.
Okay. Okay.
Okay. Designated. So that's going to leave switch 3 that his gigabit Ethernet 0/1 is going to be a blocking. port.
Yep.
Okay. Well, egress. Yeah, egress.
So think about this. Think about this. There's simply 4 things that you really got to focus on when you're dealing with spanning tree and converging it by hand. Number one, we know we got to find that root bridge out the gate. We need to identify that one, right?
Yeah.
From there, we're going to span out, and we know that that root port is going to have, I'm sorry, that root bridge is going to have designated ports on all its active ports. Okay.
Right.
So we know that out the gate. We can put big D's on those ports coming out of that root bridge. All right. Now, next thing we got to do, all right, we got to find root ports. So that's when you start looking at all the switches and start saying to yourself, all right, what's my lowest cost to get back to that designated port that sits on that root bridge?
Right.
You get me?
Mm-hmm.
Once we do that, we also know that on the other side of those root ports, what kind of ports are going to be on there? Because that's where our traffic got to go.
So it has to be
Right. Say it again.
designated.
Right, because that damn traffic got to get through there.
Mm-hmm.
Okay. So you can also turn on one designated port per segment. Okay.
Mm-hmm. So just to confirm, designated port is all
it's in the forwarding state.
Forwarding state. Okay.
Yeah.
I have a quick question for you, Claude.
Yeah, go ahead.
So his connection is MAC 44, 66, and 22, which is switch 2, 6, and
Brian, we haven't got there yet. Give it a second.
okay. Gotcha.
Yeah.
Never mind.
Okay. So like I said, we turn on a designated port per segment because we know that the root port on the opposite end, that traffic is coming from that port.
Mm-hmm.
And we need to be designated in a forwarding state for that root port traffic to come to us. Okay. So with that being said, there's only really one thing left to do with everything else. And what is that?
Block everything else.
Exactly.
And we got, that's what I was looking for. Damn, now I can eat dinner. Yes. Yes. So, Lamar, on your interface, gigabit 0/1, what are we going to do?
Said it is can be one designated port per segment. You can elect that as designated, since that's the direction that it needs to go.
Perfect. Awesome.
Yeah.
Ramsey.
Yeah.
Ramsey, did I lose you?
Yeah, no, you can see steam coming out of my ears again. Switch 3, the bottommost, the designated. Like in the back of my mind, I'm like, boy, that should be alternate. But designated in this situation is acting as a backup, not, but then I heard you guys say forwarding. So that's where I was starting to get the, Ghostbusters, the streams are starting to cross. So
right, and that's valid. That's a valid inquiry. So remember what we said. Look at each switch in this whole topology, and whenever you guys get in the real world, look at it as a triangle, and do it from there. There's a designated switch per segment. Keep it simple. It's not going to be the same on each segment, on each triangle. Does that make sense?
Mm-hmm.
think so. So is this the correct topology, the correct STP setup? I think that's all I need to know.
You tell me. So break it down, the flow for me from switch.
It's just switch 3 is the one I'm concerned about, and it's the only one that has designated on either side.
Okay, so if I have my packet, my DHCP packet, Ramsey, tell me the path it'll take and tell me if it's the correct path.
If I have a packet at switch 3,
Yep, the DHCP packet we started with PC1.
yeah, that's right.
Switch
So it'll take the root port to switch 6.
Straight across.
Yes.
And what else?
And then it heads north to switch whatever that is, north.
4.
Yes, thank you. Yep, that makes sense. It's Mac 44.
So where is it going to go?
North to switch 4.
Why?
Because its destination has IP address 10.10.10.50.
Okay, we're talking about layer 2 now. We're not talking about layer 3.
Yep.
Why did you select for switch 6 to forward that packet that way?
Looking at the packets information. Connection through 3. So it would get updated. The MAC address, the destination MAC address, when it gets to switch 6, would get updated to destination MAC 44.
Call your lifeline.
Okay, thank you. Sir Claude,
Yeah.
what's going on is that we have the packet at switch 3. It's wanting to go to the IP address at server 1, but we're sticking to layer 2. I mean, yeah, so for me, I know it goes from switch 6 to, well, and it has to go to 4.4, because if it went to root, it would get blocked at the 10. Sorry, what's the question?
You answered it.
Okay.
Yep.
That's it. You were right. Yeah. Again, guys, I'm gonna keep challenging you. You have to be able to explain it, because you're gonna have to explain it to yourself whenever you get to this exam.
Certainly. Yeah, it's easy to get excited.
Make sense?
Yep.
It does.
I'm tracking.
I have another call to jump to, so I'm gonna bounce out. But I really appreciate this. I'm glad it's being recorded, and thank you guys for just really supporting us. It's easy to kind of chalk this off as like the easy stuff, but obviously this is the foundation. So thank you.
It was good to meet you, Ramsey. You're good.
Yes, I'm excited for the next time.
Ramsey.
Peace.
All good. And folks, on that note, our packet has reached the server. And I think we've concluded for the night. Any questions, guys?
So I have. So, when you were saying working triangles, right? There's a 1, 2, 3, 4 switches, right? Are these triangles are subject like the middle was it switch 6, 3, and 5? Would that be a triangle, or are you referring to the entire half and half?
Nope. Per redundant, because that wouldn't, switch 3 wouldn't have a direct connection to switch 2.
Perfect. So that's what I wanted to make sure, because I seen where each one where you were breaking them off into sections, but I was kind of towards when Patrick had the switch up top, trying to figure out, I guess, the parts that you would have to enter in. with being the root port, the alternate port, and also the designated port. So if his triangle was that right side, that top right quarter, and he only had that one left, I was kind of making sure I wasn't losing it, because I was like, okay, cool. The designated port is already established. The block port is not a port, route that's being used because it's not the fastest route, which I would consider to be the block port. And with the designated port being the only one left at switch 6 at the bottom left, I can't tell what port that is. That would kind of be tell where to put your 3 parts for your specific triangle. Is that correct?
That's correct.
Okay, cool. I just wanted to make sure I was reading it right, because now I'm about to go back to this topology. I think I got it exactly like that, but I know it's a few moving parts that I'm trying to still understand. But doing this multiple times with multiple people and giving each person a specific triangle, and then looking at this topology specifically, it makes sense of how everything works together.
Perfect. That's good. Awesome. All right, folks. And on that note, I'm gonna go ahead and shoot some zombies. And
I wish I could be
guys,
shooting zombies.
I just realized what you just meant. Okay, go ahead.
On that, folks, guys, rest up, kick it. Again, feel free to reach out again if you desire another session like this. It doesn't have to be as a group. We can do short sessions. We mostly do communications via Slack. If you haven't, gotten an invitation by Slack, feel free to reach out to Brian or Ramsey. But guys, you guys have a great night. Okay.
All right.
Thank you. Likewise, sir.
Appreciate it, guys. Thank you.
All right, have a good night.
Good meeting y'all.
Thank
same.
you.
Guys, so much again.